Hello, welcome to today's lesson. I'm Obed. Please don't forget to subscribe to my YouTube channel for more info. Today we are talking about binomial distribution. So we will looking at our objective. You go through binomial distribution, two expectation, three variance. Of course, if you know the variance, you can find the standard deviation. Talk about the work examples and also trial questions with answers. So we just have to work them out and compare them with their answers. So when you talk about binomial distribution, it's just about sequence of n Bernoulli trials. Yes, where we have these formulas. So the trial has two outcomes. Yeah, a success and a failure. And the x takes binary degrees, zeros and ones. So the binomial just happened to be a sequence of Bernoulli experiment with n trials or n Bernoulli. Yeah, that's all. So we realize that the Bernoulli was giving us probability of x. Then we are having to bracket 1 minus p, 1 minus x. So you realize that the n here that we have here in a Bernoulli was just 1. So in the Bernoulli we didn't have any combination because n is just 1. It's like one combination x. So remember our x just took values of zeros and 1. So one combination 1 is the same as 1. So the binomial was just derived from Bernoulli. So just n Bernoulli trials. So the probability distribution for our binomial is given by this as we have here. Yes. So n combination x, probability of x, then 1 minus p, then n minus x. So let's see the parameters. So where n is the number of trials and then x the number of success in each trials. So the p is the probability of success and the k is the failure. So let's look at the expectation. So find the expectations n multiplying p, n multiplying p, then the variance is n multiplying p then k, where k was 1 minus p. So if you know the variance, we can find for the standard deviation. So that one will just be the root of the variance as we see here in the listing. Okay, so let's look at some examples here. So we have a question here. Suppose that a probability that a man has high blood pressure is 0.51. Suppose that we randomly select sample of 6 men. So we are selecting 6 men. So that means our n here is 6. And the probability that a man has high blood pressure is 0.1. So that one will be the success. Okay. So from just reading these two lines, we have our p and also our n. So let's solve it. So that means that our n is 6, then our p is 0.15. So our K is, which is 1 minus p, is going to be 1 minus 0.15, which is 0.85. And the next question says that find the probability distribution of the random variable x representing the number of men with high blood pressure in the sample. So so we said with the binomial distribution, distribution is giving us this, the binomial trials, as we see here. This is the formula. So our n is 6, then our x to be x, then p to be 0.15, and then our k also could to be 0.85. So that means this will be the distribution for our binomial for this particular question. So since our n is equal to 6, that means x can take values from 0, 1, 2, 3, 4, 5, then 6. Yes. So with this question, we can find probability of 0, 1, 2, up to 6. Yes, that's happened to be the distribution for binomial trial. So let's go to the next question. So find the expected number of men with high blood pressure in the sample is the same as the mean of x. So our expectation of x is given by n multiplying p. So our n is 6 and our p is 0.15. So when you find the product, you get 0.9. That is the answer. So let's look at another question. So find the variance. So we find the variance. The variance is given by n times p multiplying 1 minus p. So which is our n is 6, then p 0.15, then q 0.85. So our answer will be 0.765. So this happened to be the variance. So we asked to find the variance, the standard deviation, the square root, yes, of this. So the next question said, what is the probability that there will be exactly 2 men with high blood pressure? So we are finding probability when our x is 2. So when our x is equal to 2, that means we are going to have 6 combination 2 because it's giving us n combination x. N is 6, then our x is 2. So multiplying 0.15 square, then multiplying 0.85, then 6 minus 2, where 6 is n and the x is 2. So when you compute this on your calculator, you have this value 0.1762. Okay, the next question says, what is the probability that there are at most 2 men with high blood pressure? So we have at most and also at least. So when you say at most A, it means A and everything less than A. That's in the particular range we are considering. And at least A means A and everything above A. So this is the same as at most the same as less than or equal to, then at least the same as greater than or equal to A. So at most probability is going to be x less than or equal to 2. Yes. Then x takes the values from 0 to 6. That means that x here will be 0, 1, 2. So the same as probability of x equals 0, s equals 1, then the probability of x equals 2. So if you compute this individually, so what we've written here can also be represented here. So when x is equal to 1, after that 2, up to 3, yes. So you can compute this individually or you find the sum. So if you compute it individually, you waste time. So if you do this, use this formula, it's very short. So our answer is going to be 0.9527. Yes. So let's go to another question. Another question: what's the probability that there will be at least 4 men with high blood pressure? So probability that at least means that 4 or more. So in our range, x takes values from 0 to 6, and we are talking about x being greater or equal to 4. Okay, so you can take 4, 5, 6. So you can use this formula and find the probability individually, or we can use this formula here and compute. Okay, so we have 6 combination 4, 0.154, then 0.85, 6 minus 4, which is 2, then plus when x is 5 here, we have 6 combination 5, 0.15 exponent 5, and 0.86 exponent 1, plus when x is 6 combination 6. So we have that too. So we realize that we are going to get this and this and this. So the answer is going to be 0.0059. That's the answer. So that's it with the binomials. So there is a trial question. So I'll provide you with the answers. So you have to solve it and get those answers. It's very simple. So look. So um let's look at the example. Okay, so let's go to the solution to the questions. So the reading assignment here is suppose that 25% of people in a certain population have low hemoglobin levels. The experiment was choose 5 people at random from the population. Let the discrete random variable x be the number of people out of 5 with low hemoglobin level. One is find the probability distribution of x. Second one is find the probability that at least 2 people have low hemoglobin level. And three is find the probability that at most 3 people have low hemoglobin level. Then then find the expected number of people with low hemoglobin levels out of 5 people. And the fifth one says find so find the variance of the number of people with low hemoglobin level out of 5 people. So that's the questions. So these are the answers to it. So for question one, this happen to be use this formula. Then there's a question two. After solving it, you should get this. Then the question three. After solving it, you should get this also. Then question four, you're expected to get this, and five, the answer is also this. Thank you very much. Obed. Please don't forget to subscribe to my YouTube channel. Thank you very much.